Well, hello everyone. Welcome to today's webinar on TR-069 data model testing in CDRouter. My name is Jason Walls. I'm our resident TR-069 specialist. And with me is Brad Ritchie from QA Cafe Customer Support.
Hello, everybody.
We're going to go over a little bit about what a data model is and what it means in the context of TR-069, and then Brad is going to show you how that plays out in CDRouter and the test cases that we have. So what is a data model? In the context of TR-069, a data model refers to two things. The first are the data models that are defined by the broadband forum in XML, and that defines all of the root object and all of the objects and parameters that are specified by the broadband forum as the standard objects and parameters. Those can be expanded by vendor extensions, which is explained in TR-069 on how to do that. But when you see a broadband forum official data model, they're referred to by their root object and their version number, such as device 2 or STB 1.3. STB is set-top box. And then we're also talking about the instantiated data model, which represents the current state of your TR-069 enabled device. So that's all of the objects and parameters that your device supports and are exposing via TR-069 that an ACS can control with RPCs. There are two different kinds of data models. There's root data models and service data models in TR-069. The root data models are the big data models. They're the ones that have all of the network interfaces and a lot of the diagnostic parameters and stuff. And then the service data models are additional pieces of functionality that surround like a particular kind of service. So either voice or video or a network attached storage or a femto access point. And so the service data models will appear in the data model under the service table, under the service object, and then there'll be a list of services of that type. But other than that, the root data model is the root data model. The way that data models are specified is a little confusing, and we've run into a lot of problems with this, is that the broadband forum document names only refer to the document numbers that the broadband forum used to publish parts of the data model. They don't actually refer to the complete data models themselves. Just as an example, so device 2 has parts that are published from TR-181, TR-143, and TR-157, and those things all come together when you run any kind of XML software on all of the files to generate the complete data model. It's basically importing from those documents. But if someone ever asks you to test TR-143, what they're really saying is, make sure your device supports the diagnostics parameters in device 2. So yeah, this creates some confusing in the industry about what should be supported. And just to illustrate this, I want to show you the CDRouter page. So this page here is on the Broadband Forum website, and this explains a little bit about the data models and how they are laid out. So if you see, actually, before I even go into this, if you scroll to the very bottom of this page, you'll find a zip file that contains everything in this directory. So that's basically every XML file that has anything to do with TR-069. So if you're using any tools when building your implementations, you're going to want all of those files because different data models will pull from different files and the bibliographic references and other XML concepts. So as you can see, we list the root data models. Internet Gateway Device was the original, that was deprecated. Device 1 was the original LAN side device data model, and that was deprecated. And now we have Device 2, which is the official data model. But most of if you're a device vendor, there's probably a lot of your service provider customers out there that are just asking for devices built with Internet Gateway Device, and that's basically because they have legacy deployments with an ACS that supports that data model. At the end of the day, it doesn't really matter which data model you support, as long as you're meeting whatever the ACS needs. And then you have the service data models, or the ones that I said before. So there's 2 versions of voice service. There's 2 versions of FAP service, which is femto access point, storage, and set-top box. And you can see them all laid out below, and if you actually click on one of these, it'll take you there. You'll see the version, the latest version of the data model, and then you'll see this over here actually points to the latest PDF document that is associated with that data model. And while there isn't any normative text when it comes to the objects and parameters in the PDF, if there's any theory of operations on how a set of parameters are supposed to work, so what are you supposed to do to set up a Wi-Fi network, how do you do tunnels, that kind of a thing, that's all specified in this PDF. And then the objects and parameters themselves are specified in the XML. And if you want a human readable version of it, you can go to the HTML. And if you're just looking to see what the differences were between the last version and this version, you would click on diff. And if you want to see the full version, you click on full. And then you will see the entire device 2 data model. So what about profiles? The device summary parameter has been deprecated in favor of the supported data model table, which uses a concept called device type documents, but not a lot of people use that yet. So most of your legacy deployments or the things that your customers be asking for will probably still make use of profiles to some degree, and we still define profiles for use by developers and service providers so that they can easily specify what parameters they want to be required by your implementations. The profiles list the parameters that are required to enable a particular piece of functionality that's manageable, and they're updated when the data model is updated, and they're versioned as well. So if we go back to this data model, you'll see at the bottom.
So what you're scrolling through there is all the parameters.
Right.
And then below that section is?
Below the parameters, you'll see the profile definitions. So if we were to look to download and upload, refer to, if you're going to be using this thing, supported data model, trying to find the baseline profile here. So just an example, if you supported UP&P devices, this profile would specify the objects and parameters, the minimum objects and parameters required in order to support that functionality. Or here's a simple firewall profile. So if somebody said, please implement this profile, what they really want is at least these parameters. And so the reason we talk about profiles is that is going to come into play when you are doing data model testing with CDRouter. And with that, I will hand things over to Brad.
Thanks, Jason. So on this slide, I just have a snippet of the baseline profile that's defined in TR-98. And as Jason said, the TR documents are just the document numbers that the broadband forum uses to publish data models. But it's often what people or test engineers are aware of when they are required to perform data model testing on their devices. And consequently, CDRouter also implements and provides test cases that are named after the document numbers. So you will see that in CDRouter within the test case names. And I'll get to that a little bit later in the presentation, just showing which data model tests are provided within CDRouter. So this baseline profile, as Jason mentioned, it shows all of the parameters and objects, the object hierarchy that's required for this profile. So if your device is supporting, if you want to do TR-98 profile testing, what you really want is the list of profiles within the Internet Gateway device data model and all the profile and whatever profiles your device supports within that data model. So going back, or likewise with TR-181 issue 2, that is the document number that was supported, that first defined the device 2 data model. And very often that's what you need to test when you're referring to TR-181. You're referring to the device 2 data model. And those are the two primary data models. The third one is device version 1, which was sort of a transition data model that occurred in between Internet Gateway device and device 2. So when each device supports a number of profiles and the parameters grouped within that profile. And it announces in the Internet Gateway device data model, it announces which profiles are supported using the device summary parameter. This is a parameter on the device that can be queried by the ACS to find out what profiles are supported. CDRouter also makes use of this to automatically detect which profiles the device supports. And that information is used to select which tests should be run against the device. So during CDRouter tests, CDRouter's ACS will query for this device, receive the device summary information from the device summary. If your device supports the device 2 data model, since the device summary parameter itself has been deprecated, your device likely will not support device summary. And so you'll have to add configuration information in CDRouter's config file using the TR-069 fake device summary test var. This test var takes for a value the same string that would have been returned by the device summary parameter in the exact same format. And you can see that at the bottom here. TR-069 fake device summary is defined using the string device2.1, which defines the device 2 data model version, and then the list of parameters, the list of profiles that the device is claiming support for. And CDRouter uses this information to select the device 2 data model profile tests, which again are defined within the broadband forum specification and the XML files published by the broadband forum. So when you're configuring CDRouter, whether your device supports Internet Gateway device data model or the device 2 data model, you can use the TR-069 fake device summary to override what the device actually claims support for. This can be used in instances where not just if you're supporting device 2 and don't support device summary, but even if your device does support the device summary parameter, you can override that value in order to overcome discrepancies in your device implementation, to specify additional profiles that you'd like to test. Maybe if you have a custom profile or user-defined profile that's implemented by your device, CDRouter can handle that. You can also have CDRouter skip profiles by omitting those profiles from the list that your device announces. So if, for example, your device in its inform message contains a device summary parameter that lists more profiles than you want to test, or if you want to omit some of those from your testing, you can override that with TR-069 fake device summary. You can also just have the TR-069 fake device summary test var specify all, and that will enable CDRouter to test all of the profiles that it knows about based on what you've selected in your test package. And I'll show you how that all comes together in an example at the end here. So in TR-069, the device model tests verify whether the device correctly supports all of the parameters that are defined within each of the profiles that it claims support for, whether that's using the device summary parameter or whether it's using the one that you've specified using TR-069 fake device summary. support for the parameters is verified using, it checks whether each of the parameters is available in the data model. And for each profile defined, CDRouter will run through a set of 7 tests. It'll use the get parameter names RPC to verify that the device is announcing support for the parameter, basically listing that it knows about the parameter and whether the attributes for that parameter success are correct, meaning is it a read-only device, a read-only parameter, or does it support reading and writing? It also uses the get parameter values RPC to verify the value of the parameter to make sure that that parameter can be retrieved. It doesn't actually check specifically what the value, whether the value is correct based on the functionality, but it does make sure that each parameter can be queried using get parameter values at the top from a single RPC to query all parameters, and it will, or to query individual parameters one at a time by name. It also tries to set parameters to their current value to make sure a set parameter values RPC is successful. Again, this isn't specifically trying to change parameter values specific to any functionality, but it ensures that the data model supports setting for writable parameters. And then likewise for objects, certain parameters can support adding and deleting of objects, such as port mappings, for example, can be tested to the port mapping objects can be added and deleted by the ACS, and this CDRouter's data model testing will verify that objects can be added and deleted in the data model. We've also added recently the ability to, when the device returns a value and when CDRouter's ACS queries the device for parameters, the syntax of the parameter itself, its encoding and its value type are checked against the XML document to make sure they're consistent. So each parameter returned by the device needs to be encoded with the correct type. If it isn't encoded with the type, it needs to match the XML document definition, and also to make sure that the value that's returned is consistent with any modifiers, such as the length of the string. Certain parameters are limited in how long they can be, and that would be specified in the XML document. CDRouter will check for that, or the integer range is within the range specified, or if it's an object that supports a certain number of specific enumerations, CDRouter will make sure that the value returned matches one of those enumerated lists. So this data validation is enabled by default, and it will cause a test to fail if any discrepancies are found in the encoding or in the value range or length. So if you want to disable the validation part, you can use the CWMP data validation test var and set that to no to disable the validation, and still check just to make sure that the parameters are returned without going further to check the syntax. So in order to perform data model testing on profiles, you'll need the CDRouter TR-069 add-on in your system. The TR-069 add-on provides data model testing for the root data models. The TR-98 profiles module tests the Internet Gateway Device data model and provides testing for all the profiles defined within Internet Gateway Device. TR-106 is for the device 1 data model, and TR-181 I2 profiles is for the device 2 that's defined in TR-181. We also offer the CDRouter TR-069 EDM, that's extended data model. This add-on provides profile tests for a number of other service data models that are published by the Broadband Forum, such as for VoIP devices, set-top boxes, and so on. This is a separate add-on that can be purchased in addition to the base TR-069 add-on. So right now I'm going to show you an example of some test results. There we are. So here I have an example where I've run some data model testing. And we have a package here in which we've selected a number of the TR-98 profiles. We have a device that supports Internet Gateway device. So we're testing the baseline profile, the Ethernet LAN profile, USB LAN, and so on. When we go in, we can select the test module and the test within this module that we want to test. Once we've selected all of our tests and saved it and rerun the test, CDRouter will then connect to the device during the test startup as part of the normal initialization process. And you can see in the start log, TR-069 initializes all of its protocol stacks and connects to the device, assigns an address, and so on. And then as part of the TR-069 initialization, it will check the device summary parameter or the configured TR-069 fake device summary for the list of profiles that it should test. And it will compare this information to determine what the device actually supports. So that it takes what the device actually supports and matches this up with the number of tests that you've selected. And if you've selected any tests for which the device does not claim support or for which you haven't configured in your TR-069 fake device summary, it'll automatically skip any of those tests. So you can see here, we'll list all of the tests that it's going to skip, basically indicated because the device doesn't claim support for it. So you could literally select all of the tests within CDRouter, but CDRouter will skip most of them and only run the tests for which it sees that the device supports that profile. So once we run the test, CDRouter goes through and queries the device using RPCs geared for that test, runs through each of the 7 tests geared toward verifying the data model. So it runs the RPCs, gathers the results returned or the value returned by the device, and then validates whether the device is supporting all of the parameters correctly. So you can see in this one, it queried the baseline. It ran a get parameter name RPC against the device to check for the baseline profile. Indicated that it found there were some parameters that were not returned that were defined in baseline, but because some of these were not required, that doesn't fail the test. But there was one parameter here, this RSIP available, that was not returned by the device, but it was a required parameter. So this caused the test to fail. If you go into the next profile, the Ethernet LAN profile, this one passes because all of the tests are, all 40 parameters were were returned by the device. So there was nothing missing, so the test passed. Further down, we can see an example of data validation. Here, all 12 parameters were found on the device, and so that section of the test failed. But then CDRouter found that a few of these parameters did not contain a value that had that wasn't consistent with the device definition. In this case, these 3 parameters returned a null value rather than one of the enumerated types that was defined by the parameter. So this caused the test to fail. So this is an additional check in addition to just verifying that the parameters exist. And we have another example here of range testing, where we can see all the parameters were found, but certain values contained a value that was out of range, where these were defined within the spec, within the XML spec, as being having a minimum value of 1, but the device returned 0. So again, this additional validation testing can be disabled using the CWP data validation test var. And again, this is for the Internet Gateway device data model, which is what this device supports. And you can go into the package. The package provides all of the tests that are available within their modules. So Internet Gateway device is TR-98, TR-106, device 1, TR-182 for device 2. Had I selected all of these would automatically be skipped because CDRouter automatically detects that device 2 is not supported. So even though, and I just highlight this because each data model defines the same or many of the same profiles. So you'll find the baseline profile within all 3 of these data models, but you need to make sure to select the correct root data model that matches your device. So that pretty much covers all of the basics of data model testing within CDRouter.
Are there any questions so far?
Okay. So that covers data model testing. We're going to be coming up with more webinars in the future to cover other testing aspects in TR-069 and other areas supported by CDRouter, such as IPv6. If you have any questions for us, or if there's anything that was not clear in the webinar, please feel free to give us an email. Send us an email at support@qacafe.com. We'll be happy to answer any questions, or if you have any trouble setting up CDRouter to run these tests, send us your results, and I'll be happy to help you out.
Thanks, everyone, and enjoy the rest of your day.